and you put it into a bank account with 100% interest. What did you get out at the end of a year? $2. Okay, so 100% interest, the maximum interest. Okay, now if you bring that to our compound interest formula, which is the FV is PV 1 plus rate over 100 times KN. All right. Let's look at 100% interest and what happens here. So if we start, we're always starting with $1 here. So if we start with a present value of 1 plus interest rate of 100 over 100K, and let's just say 1 year for the moment. Okay. So N is 1 year. Okay. If we change the amount of compounding times that happens in a year, like for instance, we say, all right, it's not compounded just once in the year, it's compounded twice in the year. Wouldn't K be 2 here? Yeah. So the ones would cancel and you get, or the hundreds would cancel, you get 1, well, you don't even do the 1. You end up with 1 plus 1 over whatever the K was, K, and that's 2, yeah? So you can do 1 plus 1 over 2 to the power of 2. Yes? Does that make sense? For if it compounded twice in the year. What's the value of that? Is that going to be more than 2 or less than $2? If it compounds twice in the year. You'd expect it to be more than 2, because after 6 months you get that compound interest and you put it in again. I know the interest rate is also halved, but it's compounded twice, so it should win. Well, let's see what it is. What's 3 over 2 squared? 9 over 4, yes. So that's 9 over 4, which is decimal 2.25. Yeah? Okay, let's increase that then. Let's say, right, instead of it compounding twice a year, let's do it 12 times a year.
That's a lot.
I know it's a lot. Well, this is where calculator can be useful. Yeah. So anyone got a calculator in front of you, just type in this. So if it compounded 12 times in the year, how much would it be?
Give me a moment, please.
So one time a year, it's $2.
So 13 over 12 is our 12.
Yeah. 2 times a year, it's $2.25.
Wow.
12 times. What is it?
169 over 144.
Can you get me it as a decimal? Is it going to be more than 225?
This calculator is so annoying.
It should be. You just do it.
Just decimal. 1.1. 1.176. Wait.
I've already put in the 2.
What? But look, am I wrong?
What do you do? 13 over 12?
Oh, I did it squared, not to the power of 12.
2.6?
No,
2.61. Thank you. 2.61. Okay. Let's say we do it 100 times. So if you have that already in your calculator, you can just put in 100 instead of 12. Type it in again.
But now it's a different number.
No, just rub out 12 and put in, every time you 12, put in, put it in as 1 plus 1 over, and then it'd be easier. So if I do 100, if it compounds 100 times in the year, what is it? $2.70. Okay, so what are we looking at here? We're looking at it's increasing but slowing down the rate of increase, isn't it? So do you think it's going towards one particular number? So if we have infinite times, what would that be? Well, we can't get it on the calculator because you can't type in infinite.
Euler's number.
You talked about E before.
I have, yeah. It gets to 2.7. The closer we get to infinity, the limit of this setup, same as if you cross the room in halves, you never reach the other side. But the limit is pretty much you reach the other side.
You reach it technically?
Yeah, well, that's the limit of it. Technically, no.
Is this infinite number? Like pi? Or it has
Yeah, it's an irrational number.
it's
It's another irrational number. Yeah, remove that, and only like the HL students in the school will know what I'm on about. But this, yeah, so it's not $2. It's the E is the limit of compound interest. So that's E. E is it's another mathematical constant, 2.718, so this is the same as pi is a mathematical constant, 3.1415, and so on. So E is a mathematical constant, comes up a lot in financial maths. Right. Yeah. E is 1 over, E is the limit of this this equation. Where is it? This one. It's the limit of this. The limit of this thing as k approaches infinity is E. Now you'll never have to recreate that, but that's just interesting because it's a number that is used a lot for exponential equations and things like that. It's got interesting, actually, Aidan will know this, and maybe Priyanka. What's the derivative of e to the power of